Hello and welcome back to the channel. It is me, Mark, from Powersonic and Apprentice 121. Today we're going to look at electricalOM again, and in particular the CAD package that comes alongside that. So you can, if you want, generate your own CAD drawings within electricalOM, or as I'm going to show you today, you can import an existing design and then add your electrical installation on top of it. It ties in with the schematics that I've shown before on the channel and also the certification software. We'll get straight into it. I've got a pre-recorded clip all on the computer screen here. I'm going to chat through it with you guys watching. I thought that was the best way to try and put the video together. So without further ado, we'll zoom me down and get straight into it. So we'll jump over to electricalOM now and have a look how we get this set up. And you can see to start with, I'm creating some different layers. So I've got my base layer, which is the CAD drawing itself. I've then got an electrical distribution layer, sockets, lights, and EV. And the reason for that is to stop the drawing get too cluttered. If you break it down like that, it's easier to read in both the 3D view and also the 2D view you can see here. We do need to set the scale on the drawing that I've imported. So this is an existing CAD drawing. There's loads of node lengths on there. You just need to pick one and then measure between the 2 points. It'll pop that in, and then anything that you do after that fact should bear a relation to the scale within the planned drawing. Now I should say this CAD drawing isn't exactly to scale anyway. It's not something that's been done by an architect, it's been done by the homeowner. So there are a few discrepancies in there, but it's going to give us a good idea for running through this example. You see I've dropped a distribution board straight in. This is a single phase domestic setting, a 14-way board. We're going to use a Proteus one, and I'm just dropping the meter onto the same wall in close proximity to that. Now you can use a snap to fit drawing for the wire, but I'm going to do this one manually. You just need to link the 2 points together, because if you don't, then the software won't see that those things are connected. So I'm just going to drop a wire in. If we jump across to the schematic, you can see it's understood that, and we're just going to make some changes to some of the defaults that pop up when you do make those connections. It does it if you're doing it in schematic mode or in CAD. You can adjust what they are, but I just need to make sure we've got that set right for what's going on the wall. So I'm changing the conductor sizes and getting rid of some of the isolators that aren't actually there. You can see here now I'm going to jump into the socket layer. We're going to drag some double sockets in and start positioning them around the walls. We've got the snap to fit feature on. I've got the wiring toggle on, so as I drop these in, links between each one should start to form into position as I drop them onto the wall. And you can see that happening here as we move around those two bedrooms. Now it hasn't put a socket circuit direct back to the distribution board. We have to do that ourselves, and that's because really the software doesn't know if this is a ring or a radial at that stage. We are a radial circuit. This is going to be for the ground floor bedrooms, so we're going to label all of that up, and it should pre-populate straight into away on the distribution board, and you can see it's done that. I forgot to tick away all the prefix options, so we do have a bit of text cluttering things up, and we'll change that in a minute. You can see here we're going to go to the circuit edit section now, and we can choose our overcurrent protected device. In this case it's a Proteus 20 amp RCBO. We can select our cable type, which is a 2.5mm LSF twin and earth cable. So you can see we've made those adjustments. Tick the 70-degree box because we haven't got circuit accessories that can run at 90 degrees. And again, we can just choose the method that the cable's been installed. And in this case, it's going direct into the wall with some capping over the top. So we can tick all of our box to say that we've done everything we need to do in terms of regulations. We're getting the prompts within the software to do that. Set a value of natural leakage you might expect at every socket outlet, so the software can factor that in as well as it's running through doing its magic. You can see here I'd made a mistake on the incoming earth. I hadn't set it to be 16mm, and I'd had it way too long as well. So I'm just adjusting that because it's flagged up an issue within the software. So it's great as you go along, it does that. The 3D view is absolutely brilliant because it makes it really obvious if you have made a mistake. I've made a glaring one here. I had the cables set to 0, so effectively they were running in the floor void. But these are concrete floors, so all the cables are going to come from above and drop out of the ceiling. You can see I've adjusted one there. We can see that it's now popped that up into the ceiling void, and we can just highlight all of the other wiring routes now and set those to the right height. And you can do that before you start dragging and dropping stuff onto the CAD drawing, but if you've forgotten, easy done. It's really quick to make that change, and you can see I've just done that there, and we've now got the wiring dropping out of the ceiling down to each socket, which is fantastic because that's what we want. We're going to add some USB points now, so these are just the side of the bed, and again the wiring's going straight between each point. As soon as you right click off, because I've got the auto create circuit after insertions, it pops up with this box. You can assign it to a way in the board and again dictate exactly what this is. And I think here I'm going to change the elevation again because I can see I've made the same mistake twice and it's still set to 0. So we will have to make that adjustment. See, I just get rid of those there, and we'll set the elevation to be the correct height as well. And with these ones, I've done the snap to fit. I'll demonstrate that later on in the video as well. But for the minute, we'll just call this one the ground floor bedroom USB sockets. We're going to run through and select our cable type again. So the XLPE, run at 70 degrees, 2.5 mil, and then make sure we're checking the Proteus RCBOs. And again, this one's a 20 amp, 30 milliamp type A RCBO. So we drop that out the drop down, tick our boxes again, set the values for any natural earth leakage, check back in the schematic to make sure it makes sense. That's tick away the AFDD point. And this time I'm going to get rid of those tabs and tags that are on the drawing because it is starting to get a bit cluttered. You can do them individually if you just want to get rid of the odd one or two, or you can select them in bulk as I'm demonstrating here and get rid of those all at once. And it really does clean up the drawing, which makes things easier to read as you're dropping stuff in and out of the drawing. So we're going to move on to the lighting layer now. And you can see with this first drop, I've made a mistake. I forgot to tick the wiring link between those points. So I need to make sure we tick that box and snap to wall. And we're going to run through and drop the pendants in each room. There's no snazzy spotlights or anything going on in here. It is just basic central light fittings. And again, you can define that when you right click away to say you're finished, that this will auto populate onto the circuit details, ready for you to make those adjustments in the circuit edit feature. I am also going to add an external light as well. We'll do that in a minute. I'm going to drop in and set some heights for light switches now. So these are light switches going on the wall in each room. You don't have to define which light they're actually switching while you're dropping them in, so you can go around and do them all on bulk. And you can see here I'm just dropping one into every room. Make sure we've got them in the right place in relation to the lights that they need to switch. I'm also going to drop this external wall light in now, and again we need to set that a little bit higher because it's going to be above a doorway. But this is just to keep the outside lights on a separate circuit because you get a bit of moisture in it. You don't want it taking all of your lighting with it. So now I think we're going to do some wiring between accessories. So you can see first up we're going to drop a cable route out to that external light back to the distribution board. We'll just drag that out of the way a little bit to make it a bit easier to read. And then we're going to start joining the dots for everything else. So we get the pendant circuit running back to the distribution board, and then the appropriate switches linked into the relevant pendants. So this is kind of a 3-plate approach, whereas the external light is 2-plate. We're taking the power to the switch and then out to the light itself. Now the 3D function is really useful here again because you can check that you've got all of your heights set correctly. Anything that you've not done becomes obvious. You can see I've clicked off and seen that I've not set these to the right height again, so we make that edit, and hopefully now we will have all of the cabling in the right place. As you see, if I drag that 3D view in, we've just got the layer on for the lighting in the distribution board, and we can see all of those drops are running in the right direction. So now we can move off and go through the circuit edit features again to set what cable types we're using. In this case it's 1.5 mil LSF, and the breakers need setting accordingly. So we've got our 6 amp 30 milliamp RCBOs for both of those two circuits. And again, you'd expect a little bit less natural leakage from each one of the fittings that have been used, so we can define that too within the software, as you can see me doing here. And now we can have a quick check in the schematic, make sure that all looks as we intend, jump back onto the circuit edit feature and drop in some more sockets, because there is another radial circuit that needs to run around the store and the hall. This again is just going to be a 20 amp radial. There's only 3 or 4 sockets going in here. It's just for someone plugging in a Hoover, or perhaps a battery drill in the storeroom, whatever the customer might be using. And again, you can add a prefix and description. So in this, we're just going to call it the ground floor store and hall sockets. Again, that it's a radial, and assign it to a way in the board. Make sure we've got our 3 meter height set. Drag the cable route out the way so it makes a bit of sense on the layout. And again, tick the run at 70 degrees, the XLPE cable. Make sure you're choosing the right overcurrent protected device, which again is a 20 amp RCBO, and set the leakage value as before. You can see here you can actually tick into this box and it'll explain to you what your zones are as well, should you need to know that through the course of the design. The help and features through this software are absolutely brilliant, and there is a really good technical help file on the electricalOM website and loads of videos you can go off and watch as well. You see here I'm going to set an EVSE point on the wall. So this is in the EVSE layer and it's defaulted to the yellow colour that I preset earlier on. And we're just going to drop that straight onto the wall outside because there's no other accessories really to link with it. We're straight into the circuit edit feature. So we're going to call this the EVSE charge point. There is a drop down where you can choose what that is from the list, and you can see I made the mistake of popping the watts value in before I'd done that, but there's an electric vehicle charging equipment tab right down near the bottom there, and we now need to set that to the correct rating, the 7,200 watts for the EVSE. If we click on to OK, it will ask us to then define in the circuit edit details your cable types and everything else that needs to run alongside that, and we'll cover that in just a second. But first up, we need to drop a wire between A and B. So I'm using the by selection option here. So if you select 2 points on the schema, on the drawing, it will draw a wire between those 2 points. And again, just drag it out the way to a more natural route you're intending to use, and it will make a bit more sense on the drawing as well. So now we need to go and check our cable type. In this case, it is going to be a steel wire armoured cable, XLPE, but again we're going to tick the 70-degree option because we're not 100% certain that the electric vehicle charge point would be happy running at 90 degrees. It's not really necessary, so we'll just tick that off on there as well. We don't need an AFDD. We need to go and check our select our breaker value, so again the Proteus RCBO, and this one again is going to be a type A 32 amp, and we got that in there as well. So we can also create a really powerful materials list through the course of this software. So you can see I've gone back to the distribution board layer and I've assigned a Proteus 14-way board onto the distribution board. I've gone into the socket layer now and I'm going to select all of the cables within that layer, and we're going to assign that to a 2.5mm LSF cable. So if you see I've created that in there already, if I tick on that, those 10 wiring selections will all define themselves now as 2.5mm LSF on our materials list. So we now need to go and create the socket outlets, and excuse the bad spelling of white there, so I've not noticed that while I've been recording the video, but we can select those now, and if we run around and choose all of those sockets on our drawing and then make sure we tick that into the list at the side, we will be able to get a list of materials ready to take off to the wholesalers or check we've got stock in the unit straight on for this job. So we've got our 9 items in that case, and I'm just checking that off camera to make sure it's populating over to the list of materials, and it is. And here we've got some USB socket fronts, so we can create those as a new item. So again, white plastic, double sockets, and if you do make a mistake you can edit the description really easily. So you can see here I've missed off the crucial USB, so we're going to pop that in there as well, tick onto those, and we've now got those 4 USB sockets. And the same principle on the lighting layer, select all of your cables. So you can see here we've got plenty of cables dropped around on our drawing, but make sure you do highlight them all, and then if you run off and choose the wiring code at the side again, you can create a new one, and in this case it's 1.5mm, so we need to add a new one of those over off on the properties tab into the wiring codes, create a 1.5mm LSF and assign those 14 wiring routes to that. Same with the pendants, go and select them all, drop it into the code that you're going to set these to. So in this case we're going to call them pendants, and there is 6 of those on there, so as soon as we've assigned them onto that list it should populate over to the materials list ready for us to see. And that just leaves us these light switches. So again, you go off and select them all, pretty straightforward, just click on them, go to the item code, create a white plastic light switch. So in this case these are single gang light switches, drop it into your list and assign those to them. And we've just got the EVSE layer to cover off now, so we've got our My Energy Zappy, which is 7.2 kilowatt single phase one. So we select that on there, it's going to add that onto our list for us as well. And then obviously the steel wire armour cable that is feeding it, just to make sure we get that onto there too. So in this case it's going to be 6mm 3-core XLPE steel wire armour. So we can drop that in there as well. Now if we drag in our list of materials now, they should all be in there. So we'll get lengths of cable we're going to need for our different sizes of LFS and the 6mm XLPE cable. We've also got all our circuit accessories listed there as well. So if you go into the schematics, that will also pre-populate over into the forms aspect, and in this case we can see our distribution boards are filled in for us by default. So we've got all of our overcurrent protected devices in there, the number of points, the wiring type that's been used, it's all in there ready to just enter the results, which is absolutely brilliant. You can check your calculations as well. So if you want to pop into the schematic what the expected values of ZS are, for example, you can show that on the schematic. So you're getting all of that information and data at the design stage, and it's helpful when you come to compare that to testing, as I've shown before. Now, if we look into the reports aspect on here, we can generate a huge report that will base itself off that CAD drawing we've done, all of the circuit edits and schematics. All of the usual information's in there, so we've got all of the stuff to do with the cable types that have been used, the overcurrent protected devices, any selectivity issues. Everything's detailed within these reports. But the thing I wanted to show was what's outputted in terms of the drawings, because they're quite useful for us when we go off to site as well, that we can see the schematic layout and the ways in the board we're wanting to use, but also the position of circuit accessories and the planned cable routes that you might be thinking of using. So if you've got a wider installation team, really good to pass on to them. Tick them off as you go. There won't be any mistakes. You can also get them signed by the customer to make sure that they're happy with it. And you can see the different layers here. They produce themselves in separate layers, so it's not too cluttered with different wiring everywhere. So you can see exactly what the intention is from the wiring design that you've used. I think that's a brilliant bit of software to help us as electricians. I know there'll be some big design teams who use this on massive projects. So if you're doing a commercial fit out, for example, you know, you'll have all of this designed up to the finest detail, and it'll be needed because you've got an installation team that could number hundreds of people in the end. So you absolutely must have that. But even at a domestic level now, when you're trying to quote things accurately and make sure that you really have remembered every single bit that you're putting into a spec, you know, if you've got a CAD drawing, even if it's one you've done up yourself roughly within the software, it's going to really help you. You can generate your bill of materials, you can have a good estimation on the amount of cable you're going to need if you're not quite sure. You can show it to your customer and make sure that they're happy with the layout that's been selected based on, you know, what they're going to use these rooms for. And it's a way to kind of level up your presentation at the quotation stage, I think. If you can hand someone over a pack like that and say, this is what we're going to do, this is what you asked for, it can give you a leg up on someone who might just be throwing in a price for an installation, for an example, just on an email. So you can set yourself apart really nicely by doing that. But equally at the handover stage, so when you've completed a project and we need to produce these handover packs now, or at least we should be doing on all works that are done, you know, this software just does it for you at the push of a button. There's no messing about trying to have to generate something else. If you've gone through the process of designing it in electricalOM, then installing it based on that design and testing it in recording the results of that within the software, all of that data is amalgamated together to output a report you can hand over to your client. You can leave it with a distribution board as well. You can have all your circuit charts produced. There's that continuity as you run through the whole thing. It's off the scale amazing. So if you want to try this software, there is an option to go and have a free 14-day trial. I'll drop a link in the description of this video that will take you over to the electricalOM website. After that, there's loads of different packages available with add-ons that you can drop in based on what you're anticipating your usage might be. Obviously, if you're a large contractor, you're going to need some of the bigger packages. If you're working as a sole trading individual in the domestic sector, perhaps not so much. And they've catered for that in the various offerings that are out there. I've been using it now for a year or two, and it really has revolutionized the way we design, install, and hand over commissioning packs at the end of work. It really is a good way to set yourself apart, both at the quotation stage using some of this that's kind of built in, and also when we're handing over these completion packs that we should all be doing. The data's already in there. If you've gone through the process of doing the design, carrying out the installation to that design, and then testing it and inputting all the data back in to the software, the output and data that gives you to then hand over as a certificate of compliance on everything that you've done is off the scale amazing. You can leave all of that stuff with the distribution boards. You can hand it over to the customer both electronically and printed out should you wish. And yeah, it just gives a much more professional look and feel to things as well, especially with the data that's needed in and around solar and battery storage. Even if you're operating in just the domestic sector, this is something that you need to start looking at, in my opinion. And yeah, go and check it out. Have a play around with it yourselves. The guys and girls at electricalOM and ModeSoft are absolutely brilliant in their customer support and the way they will engage with their users. So if there's certain tweaks that you need within the software, I know from people who I speak to who have had those changes made for them, they're always listening to the user base. There's loads of good events and webinars that they put on to really give back a bit of help and support as well. So if you want to go and check those out and learn a little bit more about how all of this works, again, there's a link in the description of this video. If you've got any questions around the content yourselves and you want to ask me about something I've shared in this video, please do drop them in below. I'll happily try and help. I'm not an expert on all of this, to put that out there. I'm not brilliant at CAD drawing. It's an area that I need to improve upon for sure. But the software here is helping me do that. It's taking me on that journey and helping teach me little bits and pieces that I am going to need to know whether I like it or not in the coming months and years. And yeah, just check it out. Catch you all in the next one.